Great, thanks everybody. Thanks for coming. Hey, when we started thinking about this subject, initially everybody goes to cryptocurrencies and whatnot, and whatever your opinion is on those things. But if you dig at them a little bit, sooner or later you come up with blockchain. As a result, I've worked with these two gents to my left. They'll get introduced here in a second. We all worked on projects that resulted in the blockchain discussion. I thought it would be beneficial to share that with the EDA community. You guys will be the judge after the talk. We'll go about a half hour. Since this subject is kind of new to everybody, it's a little different format than we usually do. I'm going to introduce James and George, and then we got a quick, what is it, James, 9 slides, something like that? Yeah. We got a 9-slide presentation where we want to sort of give you a base level blockchain discussion. And then I'm going to ask George to kick in a little bit and talk about his experience on the semiconductor fulfillment side. And then hopefully we don't run out of time. I'll try to make sure we don't. And if you have some questions, be happy to answer them for you. This is James to my left. James is many things, as you can see by his resume. He's a practicing patent attorney. We work on that quite a bit together, but we also have the opportunity to occasionally bid on some big projects that are starting to deploy blockchain, and hopefully he'll talk about some of that if he doesn't feel like we're doing something wrong. So anyway, it's great to have James here. He's interesting as a lawyer, especially a patent lawyer, because he's got a technical background. He's worked with a lot of companies, principally in Southern California. George joins us today too from Baysan, where he's the marketing research advisor. Honestly, I've never seen that title before, but that's a good one. Thank you for that. Semiconductor strategist for sure. Smart guy, went to Stanford. He's got some insights into the semiconductor business that will probably have a lot of relevance for this crowd. And I'm looking forward to hearing what he has to say. Actually, we've been talking for about a half hour, and I've already learned a bunch of stuff, so I hope you guys have the same experience through the course of this presentation. I'm going to hand the clicker off to James, and we're going to get through the 9 slides and then get into the discussion. There you go, James.
Thanks. Okay, so really the focus of these slides is just to provide some base level background on blockchain, and our focus is going to be on the evolution of the technology with a focus on enterprise blockchain applications and less focused on crypto. So what is blockchain? You can think of it as a general ledger in the accounting sense. More specifically, blockchain platforms provide a peer-to-peer electronic ledger. These ledgers provide unalterable records of transactions. The transactions are put into the ledger using a unique cryptographic hash that has some interesting properties that we'll discuss in a moment. Transactions are linked to the identity of typically in an enterprise system, the transactions are linked to a participant in a business network that has a specific known identity. Transactions can also be placed into the blockchain using something called a consensus mechanism, which is very typical in the crypto sense, but not always in an enterprise system. And then immutability. Transactions are immutable. Once these transactions are placed into the ledger, they're unalterable. There's been quite a few technologies that have emerged for the enterprise use of blockchain. Ethereum, virtual machine, Hyperledger Fabric are 2 of the platforms that are front and center. Both of those stacks are available on AWS as part of the AWS blockchain stack. The IBM Cloud provides Hyperledger Fabric. The Microsoft Cloud provides Hyperledger and EVM. number of other cloud providers are providing managed services that deploy these things and make it very easy to use these technology stacks. The nuts and bolts of how you develop for these stacks is a little involved, but generally they involve something called chain code. In Hyperledger Fabric, chain code can be developed in a number of different languages, Java, JavaScript, and Golang. For Ethereum Virtual Machine, chain code is developed using something called Solidity. So again, some of the key concepts behind blockchain: immutability, consensus, provenance. Immutability we've talked about a little bit already. Once a transaction goes into the ledger, it is placed in the ledger in a way that makes it tamper resistant. It's a write once record, much like an accounting system, a general ledger system. Consensus.
Well, you know, a good question George had is, said, what happens if you make a mistake? So if you make a mistake, it stays. You just reinstitute the transaction. So you never erase it.
Yeah, that's right. So there, I'll mention this in a minute, but in these blockchain stacks, Hyperledger Fabric in particular, there's the concept of the transaction log, which is the ledger, the history of all the unalterable, immutable transactions, and then there's the world state. So if you need to correct something, you would write a subsequent transaction, which would modify your world state, but the transaction history maintains intact forever. Consensus is very important for crypto currency applications. It's of blockchain. This is the foundation for the solution to the double spend problem in Bitcoin. Very much discussed and talked about. In enterprise systems, the consensus mechanism is pluggable typically. So for many use cases, there may not be consensus, a consensus mechanism that's specifically employed. Such transactions may be allowed into the blockchain based on the concept of a trusted identity, for example. Provenance is the concept of being able to have a chain of transactions that document the history of an asset or perhaps data, and it's very important for things like supply chain. We'll give some examples of that in a moment. Private versus public ledger.
You know, provenance is a pretty big deal. So you go to Kmart, you buy an ink pen, right? And so that ink pen you bought from Kmart, is that ink pen actually legitimately bought by Kmart, or was it stolen? And so it's that's what provenance is, and that's why you need to know it. It's really important in the supply chain.
Again, given the limited time, I mean, each one of these things could take on a very lengthy discussion. But
see, he's cutting me off.
So we're but yes, you know, provenance becomes very.
Whose panel is it anyway?
Yeah.
Keep going.
No, it's a great point, Jim, and you know, provenance really, to me, is kind of the killer app for the enterprise blockchain.
I agree.
Stack, right? And it becomes very important whether you're tracking shipping containers or the origin of foodstuffs, food products, all the ingredients. There's a lot of work going on to apply this technology to all of those things.
For example, you're in China, you want to make sure you're not buying beef from, say, United States. You want to know where that's coming from.
Perhaps.
Yeah, perhaps.
Some other key concepts within the enterprise blockchain world is the idea of a private versus a public ledger. A lot of the enterprise applications employ private ledgers, private stacks. The blockchain, of course, is a foundational concept. Smart contracts, those typically refer to programs or code written in chain code that perform certain agreed upon functions that generate transactions in the blockchain based on the occurrence of certain events. Trusted computing is another term that you might hear in the context of enterprise blockchain. Typically refers to a smart contract. The blockchain itself is often referred to as a system of proof. It's a forensic record. And just generally, this is kind of a paradigm shift for software developers and engineers. The way that you develop for these stacks is new and a bit unfamiliar at this point. So this is just a notional diagram of what a blockchain stack might look like. There is a role for hardware in the enterprise world, I believe. So, and there's a number of protocols that are out there now. The predominant ones for enterprise are Ethereum Virtual Machine and Hyperledger Fabric, which is open source project that was sponsored by the Linux Foundation. I won't go through, this is a dense slide, but let's just talk a little bit about the nuts and bolts of how enterprise blockchain actually works. So the ledger specifically is a sequenced, tamper-resistant record of state transitions. And these state transitions are a result in Hyperledger Fabric, for example. These state transitions are a result of chain code invocations, which are transactions that are submitted to the blockchain by participating parties. And these transactions result in a set of key value pairs that are committed to the ledger as creates, updates, or deletes. So that specifically, answers the question. If something changes, well, then you're just really generating new transactions that are coming into the ledger. All the transactions stay intact. The ledger is comprised of the blockchain, which stores these immutable sequenced records of blocks, as well as a state database that maintains the current state. So really, the block, in something like Hyperledger Fabric, there's a transaction log and a world state. The ledger can be partitioned typically into something called channels. Each peer, it's a peer-to-peer system, so the ledger is replicated across many peers. The transaction log, the chain of transactions, is structured into hash-linked blocks where each block contains a sequence of transactions, and the blocks headers include a hash of the block transactions as well as a hash of the prior blocks led transactions. So this is really the meat of what gives rise to the notion of a blockchain and the essence of what makes it unalterable, because all of these transactions on the ledger are cryptographically linked together, so it's not possible to tamper with the ledger data without breaking the hash links. So the hash of the latest block represents every transaction that has come before it. So again, this is just a little bit of the nuts and bolts of how these things actually work, and why it's useful, I think, is pretty apparent. These are some of the benefits for things like supply chain. Again, I'm just trying to get through these rapidly, Jim. We've got a lot of slides to get through here. Asset provenance, big deal. Has your supplier sent a full order? Where is an asset at some point in time? So this augments track and trace systems. Who owns an asset? Who is handling it? What's the state of an asset? Did a shipment depart on time? Where has the asset been? Is the asset what was ordered? And then, thinking about how these, in a system based on blockchain for something like supply chain, there's intermediaries that perform roles that result in blockchain transactions, and these things establish trust. For example, intermediaries might certify goods as safe or compliant. Financing intermediaries may provide payment execution as goods change hands. And these intermediaries reduce risk, and the blockchain optimizes and automates the roles that are performed by these intermediaries and provides a level of transparency. right? So this lowers risk, creates financing opportunities, reduces costs, a lot of benefits. This is just kind of a, again, nuts and bolts. What does a blockchain look like for supply chain? Well, for every event, like for example, if a supplier receives an order, you might generate a transaction that has that supplier's digital signature, the customer's digital signature, the details of the order, and timestamps. And so for every event in a supply chain or every interaction between some group of participants, you're going to generate a sequence of blockchain transactions that can be made available to parties that participate in the supply chain to provide transparency and reduce risks. So I think that kind of gets us to the end here.
Okay.
So.
Well, I mean, great. So let's go back to the slide and then just leave that one on there. Sorry we had to do the presentation, but there's a lot going on here. But let's go back. We're discussing an example of history in semiconductor. When I first started in semiconductor, everything was done with paper. You got an order from, let's say, Delco, when I was a National Semiconductor. That would get processed through accounts receivable. They would book the order inside. The stuff would get shipped. And then, it would, all that paperwork would add about 14 days of processing time. So one of the first things that happened in semiconductor was this electronic invoice exchange occurred, and we could reduce that 14 days down to about 3 days. But it didn't have the security of a blockchain, right? So if I look into the future, I think blockchain will be adopted by the ecosystem pretty quickly. Like for example, if Apple said, I'm going to have blockchain as the way I transact things with my ecosystem tomorrow, 6 months from now, their entire ecosystem would have blockchain. And I think it's really going to revolutionize things in the next couple of years. Okay, so George is in the business of turning behavior, taking behavior and moving that into silicon, right? And maybe touch on cryptocurrency a little bit, but let's talk about blockchain right after that.
Yeah, I mean, blockchain, from a semiconductor perspective, is pretty much independent of semiconductors as a fundamental technology. It's really more of protocols that ride on top of hardware that implement the issues, the points that James was talking about, in terms of you actually write a piece of code which is a contract, and it contains all of the elements that you see here of going through the process of placing an order, tracking the order, acknowledging receipt, etc. And that becomes part of a software application that runs on top of a blockchain and uses a blockchain, I believe, to in fact validate each of those steps. So when it comes down to the hardware, if you look at what most of these suppliers are, what the blockchain companies are doing, IBM, Microsoft, etc., they're pushing this stuff up into the cloud. So they're providing blockchain capability and applications up in the cloud. And they have people that can help you build your own blockchain applications or stitch together groups of applications that they've already built to build a blockchain. Where the hardware came into the forefront was when blockchain first started out in the crypto world, because the crypto approach for consensus was this, what they called proof of work, where a very strong computational problem had to be solved in order to achieve consensus to say, yes, this is a valid transaction. That's what Bitcoin did. Litecoin had a slightly lighter version of it, and Ethereum had a different version of it. Now, if you look at the hardware world, there's a company called Bitmain coming out of China. They pretty much own the world for Bitcoin processing. They've developed optimized ASICs for doing that. They're recently started to talk about having one for Ethereum, but up till now, Ethereum and Litecoin have pretty much been supported by GPUs and FPGA boards. You can do it on processors, but processors are just way too slow to be competitive in the mining industry. As we go and look at the blockchain utilization within the corporate environment, they don't use that. That makes absolutely no sense to use mining for the consensus. It's too slow, it's too power hungry, it's way too limited, and it doesn't make sense within the context of what you call a private blockchain network, where you identify as the corporation who are the players, what are their IDs, what are their access rights to information. That is much easier, more easily defined, and by having trusted entities right up front, you don't need this sophisticated, computationally intensive consensus mechanism, where in the crypto world, where you're out there on a global basis trading coins with individuals who you have no idea who they are, you need that level of security, which was why that was put together to solve that problem.
So solves the double spend problem specifically,
yeah,
right?
Yeah, where you spend the money here and you spend the money there, and you have no way of tracing it. For the semiconductor world, if you're planning on trying to build the next greatest crypto chip, you're looking at the crypto world in terms of financial transactions. If you're looking at building the world's great blockchain chip, it's really more of a software problem. I guess if you can identify aspects of the software that can benefit from semiconductor level acceleration, there may be some opportunities there. But today's processors seem to be more than adequate for managing the corporate environment of blockchain.
Well, obviously, so where might this be relevant in EDA? Well, one place it might be relevant immediately is in license management. Everybody knows how we license things today, but what if you could say, I do a transaction between company and client, and the client, we can be assured that they receive the license as specified. Now, I've been part of a lot of EDA companies over the years, and I can tell you that all my licenses don't end up in places where I think they should. And I discover that over time, that they may migrate to different nodes that probably weren't licensed to it. So from an EDA supplier standpoint, blockchain may be the perfect thing for doing license management. So
if you do any work in parts of Asia, China, for example, the way they do that validation is the stamp of the chop on the document.
Yep. It's gonna probably be attached to license management just for not EDA, but all computer software applications pretty quickly. You guys got some other ideas on this that you want to share in terms of adoption?
Yeah, I mean, I think from a hardware standpoint, it's not that in the enterprise world. I think what's important, as George mentioned, it's not so much that you're trying to, as in the crypto world, solve a computationally complex problem as quickly as possible. But I think things like trusted execution environments and integration with RFID and being able to enhance the way that track and trace systems work in conjunction with generating blockchain transactions, those things all become very important. So it has, I think, very big potential for integration with all types of IoT technology, right? So that's really kind of, this is another layer that is coming, and there's many companies that are doing development around IoT and blockchain. And again, it's not that you're trying to solve a computationally complex problem. It's how are we going to have these devices interact with something like a supply chain network, or a distribution, a food distribution system, or I mean the list goes on and on and on.
Yeah.
And what is the role that the device will play from an intelligence perspective at automating or contributing transactions to the blockchain in a way that optimize the system. So
yeah, well, just trying to throw some examples out there, and welcome any kind of input from you guys, and then we'll ask for some questions. But if you look at IoT, edge-based devices, the majority of those devices will be image processing devices in the near-term future. So one of the problems with image is privacy rights. Who gets the information? How do you assure that what information is warranted gets transmitted to the people that are supposed to get it. I think that's going to be a big opportunity for blockchain at the edge, for example. So the people that can create that practice, both software and the hardware to support it, probably have a leg up, in my opinion.
Yeah.
You guys want to offer us any suggestions?
The baseline hardware for that pretty much exists today.
Yep.
It's how do you layer blockchain into that? I mean, there are video processors that gather the information. Now, you want to encrypt it or you want to hash it so that once it is hashed, anybody goes in and changes a single pixel, that hash is going to change. So you can secure the identity of the ownership of the video. So that's why you see companies like Comcast has a group that's exploring how to use blockchain. You've got Kodak has already announced that they're doing a Kodak coin that is being targeted at helping verify, validate ownership of images. So yeah, exactly.
Yeah, I mean, Kodak's a really great example, right? Kodak, I don't know, it's a company that's been around, for over 100 years.
Yeah.
The camera business, picture business, they've changed their name. They're Kodak Blockchain now, right? So that gives you an idea kind of how that's going to work. If you think about it, they want to encrypt and ensure that those images are owned and distributed as the owner intends, right?
Yeah.
So we can talk all day about examples. We're all excited about it. We may not look excited, but we are pretty excited about this. And so I'd like to extend the microphone to anybody that'd like to ask a question. Otherwise, you got to listen to my questions. Quit fighting for the mic, everybody. Go ahead, grab the mic. Here's another person.
Adam Kamara from Battelle Memorial Institute. I'm just curious to get your thoughts on possibly blockchain as a solution for counterfeiting of ICs.
Of ICs?
Of ICs.
Okay. Sounds like yours, George.
Sure. I mean, you can take all the information associated with the database, hash it, encrypt it, put it into the blockchain, and particularly if you take the images of the mask layers, you have traceability there. Now, can somebody knock it off and totally copy it? No, that gets back to the traceability based on date stamp and all the other information that goes along with it as part of the blockchain. If somebody comes out with an alternate one, when was it developed? When was it created? You can't go back and jump in front of something that's already in the chain. I don't know, what would you see as the protection mechanism? Because once you have that mask set, you can encrypt it. It's a great protection, intellectual property protection mechanism.
Yeah, I mean, to the extent that you can generate unique signatures for all of that, the masks, all the other information, and track that and then use it as, together with some kind of an inspection system that would, look at the chip and assert the contents of the blockchain against the chip in a way to deterministically say this is
This is not.
This is counterfeit or not. I think that will become a real thing.
Yeah, I think to add to that, I think the place you'll see it first maybe is probably DoD projects, right? Because here's the challenge. It's not exactly, are they using the information that they got? Are they introducing new information? In other words, is there something being added to the chip that may be, a listening device that was unintended, right? So blockchain will help us understand that too. Yes, sir. What's the question?
So right now, John McAfee is charging all over the world to all the blockchain conferences. And one thing he keeps insisting that seems to be running against the grain, he's insisting that there is no such thing as blockchain security. And perhaps you could have a little chat about that.
Yeah, I haven't been following him so much, but I'm not so sure what's meant by there is no blockchain security, so I might have to speculate a little bit to answer that question. I mean, it seems to me that blockchain, we went through the nuts and bolts of the hash tree and how you link transactions, and so, the ability to create an immutable general ledger in an accounting sense it's a fact, right? I mean, it's not really a disputable thing. So that is what it is. Now, the statement, there is no blockchain security, could be interpreted to mean a lot of different things. So,
Well,
you know.
Let's stay on the general ledger analogy for a second, right? So the things that make a general ledger powerful is the accounting rules, right? And then the audit function. So for audit, you need, transparency and provenance. So blockchain has that. So if somebody subscribes to blockchain, general ledger principles, then you have that. In fact, if you look at, I would argue that the number one thing America's done for the world is take general ledger and make it a accounting system that everybody adopts, and therefore commerce can, we as investors can invest in things with confidence and transparency. So I don't understand the statement as much, but my answer to it is that. I think we developed that process and capability just like we did in finance, and we can apply it to a lot of other things to ensure the provenance is correct.
I mean, if he's trying to talk in terms of homeland security, I'm not quite sure it applies at that level. But so you need to understand the context of his statements.
Yeah. It's just asking for a joke about immigration, right? So think if we could apply it to that problem, right, and just get people through in like minutes instead of waiting 18 weeks for a card where they go and get in line and wait for another 3 months, be told they're getting shipped back to God knows where, right? So, we need some efficiencies in this thing because the world has got a lot of people and it's getting more people every day. Let's find a way to do this fast and economically. I think this is the answer. Yes, sir.
Hi, this is Song from Kyoto University. So I heard that there are several hardware wallets for the Bitcoin, for the coin industry. And so I was wondering if it is kind of relevant to other applications for blockchain. Thank you very much.
I haven't given that a lot of thought. I am somewhat familiar with the hardware wallets for crypto, and I think those are mostly hardware devices for storing your private keys, right? So, in enterprise supply chain world, I guess if you had unique Ethereum tokens that had some meaning within a business network, and there were a reason to store those private keys, then a hardware wallet would also be something that would be of use. Yeah.
If we don't have that, all the guys that grow weed here in California won't be able to, transact anything, right? So interesting enough. It's a little sidebar. Then I promise to get back on subject. So my wife's a CPA. She does partnerships in California. She's over in Santa Cruz. If anybody knows anything about Santa Cruz, there's a lot of weed grown and consumed in Santa Cruz, right? And so she's got a number of clients that are marijuana growers. Now, it turns out California, it's legal, right? But it's still not legal in the United States. Federal law prohibits it, right? So as a result, you can't get a tax ID. You can't get a social security card for it. So everything you do, all transactions have to be in cash. Those are big bags of cash that walking around. So the guys that do these pot farms, you can imagine the accounting on those things is crazy. So they want, for example, her job is to take those guys that deal in garbage bags full of cash and figure out how they pay taxes. So these guys are all going to jail. They're all going to jail, man. Mainly because they're going to jail because no one can ever figure out how the heck, to account for these things, right? So here's my thought. I haven't suggested this to her yet. So why don't we start using these blockchain techniques for our marijuana growers? If I can, keep them off the weed for a day or two, explain it to them, we might have a chance. There's an opportunity, right? So I just think we'll see this. To your point, does it provide security for anything? I think it provides us an opportunity to try to secure crazy things, for example, like people growing weed and trying to, actually make a legitimate business out of it, So who are the first guys in? The drug cartels, I guess. So just like cryptocurrencies. So anyway, that probably was uncalled for, but I thought it was funny. So any other questions? Gents, any last words?
Maybe we can track the bags of cash.
Yeah, the bag of cash. We'll put a RFID on the bag of cash. That might be cool.
My only closing comments was that if you want to get into crypto, do so very carefully. If you want to explore blockchain, do your homework and figure out the value proposition for blockchain within the application you're looking for, and then work through the details of it. And maybe a gentleman like this, I'm sure, can help you.
Oh, James can help you. Yeah. Well, I want to thank our august panelists for joining us today. I think it shed a little light on blockchain. Hopefully it helped a little bit, give you a little more knowledge on blockchain. I suspect we'll hear more about it this year. We'll probably start seeing it used in a lot more security applications, perhaps. And I thank you for your participation. Thanks for coming. Appreciate it.
Good.